On problem number 27, we're asked to find dy dx at the point 1, 0. And looking at the equation, you can see we're going to have to do some implicit differentiation. So let's get started. You can tell on the left side we have the sine of something times the cosine of something. That's a product, meaning we're going to use the product rule. So let's identify. We'll call sine of pi x the first function, and we'll call cosine of pi y the second function. Notice we're differentiating with respect to x. So the derivative of this product is going to be the first function times the derivative of the second function. The derivative of cosine is the opposite of sine. Now we're going to have to use the chain rule. The derivative of pi times y is pi times dy dx. So we get the first function times the derivative of the second. Now it's going to be plus the second function, cosine of pi y, times the derivative of the first. The derivative of sine is cosine, and the chain rule, now the derivative of pi x is just pi. And that's going to equal, on the right side, the derivative of y is dy dx. So that's it for differentiating. Now, what we want to do is get dy dx by itself. So let's see here. We have, well, first let's clean this up a little bit. Sine, there's not much we can do to clean this up. We can pull out the constant out in front, and we can call this negative pi times sine of pi x times the sine of pi y dy dx, plus, pull the constant out in front, pi times the cosine of pi y times the cosine of pi x. And that's going to equal dy dx. So now, let's do some algebra. Let's get all the dy dx's together. Let's bring them over to the right side. So we're going to add this first term that has dy dx in it. And that will leave us with pi times cosine pi y times cosine pi x. And that's going to equal dy dx plus pi times the sine of pi x times the sine of pi y dy dx. Okay. Now on the right side, you can see we've got two terms with the dy dx. So let's factor out dy dx. That'll give us 1 plus pi sine of pi x times sine of pi y. The left side hasn't changed. Okay, and now we will divide. So we'll get pi cosine of pi y times cosine of pi x divided by 1 plus pi sine of pi x times sine of pi y. This equals dy dx. But now remember, we need to evaluate this at the point where x is 1 and y is 0. So what we're going to do now is we're going to take this expression and replace every x with 1 and every y with 0. Yes, all right. So we're going to say pi times the cosine of pi times y, which is going to be pi times 0, times the cosine of pi times x, which is going to be pi times 1, all over 1 plus pi times the sine of pi x which is going to be 1 times the sine of pi y, which is going to be pi times 0, equal dy dx at the point 1, 0. So let's sketch a unit circle. Okay, now let's see here. For 0 radians, we can tell that the cosine of 0 is 1 and the sine of 0 is 0. So let's see how that helps us clean this up. Pi times the cosine of pi times 0, so the cosine of 0, which is 1, times the cosine of pi times 1. Well, pi is over here at negative 1, 0. The cosine of pi is negative 1. And now we'll divide by 1 plus pi times the sine of pi times 1, or the sine of pi is 0, times the sine of pi times 0. The sine of 0 is 0. So we get 1 times negative 1 times pi in the numerator, and 1 plus 0 in the denominator. So we can conclude that dy dx equals negative pi at the point 1, 0. So let's see if that matches any of the options. It looks like this matches option D as in denominator. I hope that was helpful. Thank you for watching the video.